this video, we're going to talk about some fundamental principles about voltaic or electrical AC arcing. Now, first of all, when you're using voltaic or electric arcing, AC voltaic arcing for skin tightening, you've got to learn how to use our device set and minimum power level. Now, in order to do that, the best way to accomplish that level of manual practice is by practicing on a piece of steak or chicken, as shown in one of our previous videos. So how does this voltaic arc, or sometimes called as plasma, really works? The principle is very, very simple, and it's been used for many, many years now. Now, let's say I've got here the device, and this is the tip of the device, or called electrode. Now, I have magnified this electrode in here. Now, what we can see is that there is a certain distance that we call D between the tip of the device and the skin or any other surface, because at the end of the day, this same principle applies to many other industries, as to say welding, cutting, industrial machining, and so on. So that distance D depends on many factors. However, two main apply in our device. As I say, one is the voltage of that electrode, and another one is the frequency. So the higher the voltage, the larger the D, that distance, that minimum distance required for the electric arc or plasma to take place, and frequency. The higher the frequency, the larger that D, and conversely, the lower the frequency, the lower that D. So what we've done in this device that we have designed is we vary that voltage there, that D. And if you take our device and put the electrode under an oscilloscope, you will see a sine wave. So what we do is we vary the voltage of the sine wave. Now, at minimum power, that D is very, very small. So it is quite important that you practice a lot, because if that electrode touches the skin or any other surface, at low power, nothing happens. The arc extinguishes, almost nothing happens. But when there is a distance, the right distance, then the arc takes place. And that distance is very small, and this is why it's quite difficult the first time around to use the equipment at low power level. But as we've discussed in other videos, that low power level is quite important because it allows you a very high degree of accuracy. Now, let's talk about another important thing, which is the frequency of the device. The output frequency of the device is not the standard 50 Hz that we all know in the voltage mains, but it's much higher than that. So what is that? The reason for it is that if the frequency was as low as the mains frequency, 50 Hz or 100 Hz, 200 or even 1 kHz, we would actually feel an electromuscular stimulation. Whereas if the frequency is higher than a certain threshold, then that electromuscular stimulation is not there anymore, and therefore we don't feel the electrocution, and therefore, although we apply an electrical arcing onto our skin and our body, nothing really happens to our muscles, so we don't feel that electric shock. We do feel a burning sensation, but we don't feel an electric shock. So this is the way our device operates. What you find at the tip of the electrode is that sine wave over there. But so what is the difference between our device and electrosurgical devices? The main principle is the same, because if you've seen other electrosurgical devices, you've seen that they still produce an arc, a voltaic arc or electrical arc. But the way they normally work is fundamentally the same, but slightly different. So if you look under any oscilloscope, what you find in there, you'll see a sine wave. But if you look at what you find in the most common electrosurgical units, you'll find something like this. So the way electrosurgical units work is pretty much the same, so the physics are the same, but the way they operate is slightly different, because you find that, and the way they operate is in this way. So instead of having that, we have this particular type of wave, and in order to modulate their power and the way they operate, they apply a stepped wave. Now that is fixed, and what they do really, they either increase that step in the time domain or they decrease it. So when they increase that step in the time domain, that frequency over there increases, and when they decreases, that equivalent frequency decreases. So basically the fundamental concept and the physics are the same, but they work slightly differently. And it's only my personal opinion as an electronic engineer that this is a smarter way to design this type of units. But anyway, we've given you an in-depth some knowledge about the fundamentals of electrical arcing and how our device operates. And once again, practice generating the arc at the minimum power level, and once you've done that, then you can start quite confidently performing the aesthetic procedures. So thank you very much for watching. Right now we're going to have another video starting. It's only going to be a few seconds. It's just showing you how the electrical arc starts whenever you use the device at low power level. Thank you very much.